All right, guys. Homework from 5.5 of the text. So this is all about first differences. Um, so page 275 from the text also. 1 through 3, 4b, and 5a. 5a is kind of cool. So hopefully you give this a shot. If not, go back and pause this video and go back and try the homework before you watch the video. I am going to find the page. Hold on one second. I'm old. All right, there we go. First up, the first question is, question number 1 is asking, are these linear or nonlinear? So I didn't copy these down, but all you're going to do is look at, do they have an x and only an x? So the first one is y equals 5x plus 6. So you got an x, there's no exponent on it. It's not as an exponent, it's just a plain old x. We have order 1, okay? So it's a first order or a degree of 1 in the equation. And that means, yes, it is a line. So you have something like 5x plus 6, that's great. The next one is minus 3x minus 2. Sure, they're negative, but they're both, sure, they're negative. They're both negative, but the order of the equation is 1 because you have x just to the power of 1. That's it. And the next one, you have x squared. In C, you have x squared, so no go. Okay, and then you have 10 to the x, no go in D. E looks weird, but if you look at the x value, it is standing there by itself, and it has a power of 1 on it, or just left by itself. So it is, in fact, a line. And F has an x, but it's actually at the bottom of a fraction. That's a little weird, actually. So if you didn't get this one right, 6 over x, and you go, well, there's no exponent here. The x can't be on the bottom of a fraction. Kind of a weird rule. That's kind of a strange question, but it is not, in this case, a line. If you don't believe me, go over to Desmos. So if you go to Desmos and you can type these equations in, and then graph them. So let's quickly go over to Desmos real quick to show you what it looks like. Desmos. I was just watching my own videos.
I guess,
oh, that's my voice.
This
wow.
Works okay. I can hear a little background.
Weird. So you go here to Desmos. I'll show you how to do that. And then, so we have 3x. You just go and you type in 3x plus 6. I think that was one of the equations, or no, 5x plus 6. But so 5x plus 6 is a line also. So you can mess around with that and take a look at what these look like. And then the other one was x divided by 6, and this is a weird looking guy. So if I go x divide over 6 is x divided by 6, okay, and then it looks like, no, it wasn't x. I just said sorry, x divided by 6 is fine. Sorry, 6 divided by x is not. Okay, so 6 divided by x is the green guy. Look at that. It's weird, eh? These are called asymptotes. So you have something that breaks off into 2 different pieces. So that's the green guy. So I'll get rid of the rest of this. That's what that looks like. 6 divided by x, 6 over x. So not, in fact, linear. Anyway, if you didn't know that, no big deal. Let's look at these now. Are these linear or not? What you're going to look at is the first differences for each of these questions. So I wrote out the tables for number 2, and then you just go through here and you ask yourself, is the first difference the same? How do I go? What just happened there? How do I go from what did I just do there? Wait a second. That was weird. How do I go from here to here? Okay, so from 5 to 6, I go up 1. From 6 to 8, I go up 2. From 8 to 12, I go up 4. They're not the same, so not linear. Okay. Over here, if I go from -4 to -1, just think temperature again. I go from -4 to -1, I'm up 3 degrees. Okay. I go from -1 to 2, I'm up 3 degrees. I go from 2 to 5, I'm up 3 degrees, and I'm up 3 degrees for each of them, so this is, in fact, linear. This one here, x and y. Note for this, all of these, even though on this side they're not going up by 1, they're going up by the same number. So that's oh, they're going up 1. Sorry, I'm thinking about the next question. Okay, So they are going up by 1. Negative 1, 0, 1, 2. These guys here, from 1 to 0 is minus 1. From 0 to 1 is 1. From 1 to 4 is 3. So these are not the same, so not linear. This is the question I was thinking about, sorry. I go from minus 5 to minus 3 to minus 1 to 1. You can just kind of ignore that. This is not going up by 1, but they're going up by the same amount each time. They're going up by 2 each time, so we can still see if the first differences are the same. Are they the same? 8 to 4 is minus 4. 4 to 0 is minus 4. 0 to minus 4 is minus 4. So each of these are minus 4. So in fact, it is linear. Okay? 3a, I didn't copy out, but if you do the first differences in 3a, they're all 9.8, which is actually has to do with gravity. But you'll get to that one day in science. 9.8 meters per second squared is the force of gravity. So since they're all the same, it's linear. In the second equation, second table, sorry, if you just look at the first couple things, this goes from 0 to 9.6, that's up 9.6, and then it goes from 9.6 to 16.6, so that's just plus 7. Okay, so right away you know that it's not linear because the first two steps are not the same. So you can stop right there. So not linear in that case. 4b is kind of neat. You're looking at the bases, the base side length, and then the number of tiles in total. So just to go over that, what that means is how long is this? That's 1, and how many total tiles are there? There's 1, so the first is 1 and 1. Here I have 1, 2 on the bottom, so that's 2, and then in total I have 1, 2, 3, 4 tiles, and then the third one is 3 on the bottom, and then I have 9 tiles. 3 by 3 is 9. And then you ask yourself, is this linear? Well, that's plus 3, that's plus 5, so no, it's not. Okay, so not linear in that case. 5a is kind of cool. You have the circles, and then you have the points of intersection. So what that means is, if I have this, that's a point of intersection, that's a point of intersection. Okay, so how many intersections are not overlap, not sections? So you could do a different question where I ask you the same sort of thing, but I say how many sections are there, and that would be 1 section, 2 section, 3 sections. Okay, but that's not this question. Okay, so this question says the number of circles and the points. With 1 circle, I have no intersection. Okay, so that's a weird one, but that you think about it, there's nothing to intersect, so you're at 0. Here I have 2 circles, 2 intersections. Here I have 1, 2, 3, 4. 3 circles, 4 intersections. And basically what's happening is each time I'm adding a circle, so there's 1, 2, 3, 4. If I add this circle, I have 5, 6 now. Okay, so now with 4 circles, I have 6. If I went to 5 circles, I'd have 8. And then you notice that these are all going up 2, 2, 2. So this would in fact be linear. All right, kind of cool question. You can try 5b. I'm too old for that. But maybe give it a shot. All right, take care.